All right, so I'm just going to make you guys a video here, and I have this handout, and I'll give you the handout. I'll post the handout, and I'll also give you a piece of paper that I want you to write answers into, and that'll be worth some participation. If you're in the Monday, Wednesday, Friday sections, it'll be due the Monday after break. If you're in the Tuesday, Thursday section, it'll be due Thursday after break. Okay, so here we go. Example 1. We get f of x equals to 2x cubed plus x squared minus 3x plus 36. All right? And we get a hint that f of minus 3 is equal to 0, all right? So then the question is to factor it. Okay, so since we have f of minus 3 is equal to 0, the factor theorem tells us that we can find an x plus 3 factor in it. So we're going to divide x plus 3 into this polynomial. All right? And so, how does that go? Well, and so the handout I'm giving you, its notation is a little bit different than mine, just ever so slightly, in the sense that it distributes the minus through the terms. But I'm gonna not do that. Okay, so here we get 2x squared. All right, and then the thing is, let me just write off over to the side here the logic. We have 2x squared times x plus 3, right? That's 2x cubed plus 6x squared. Now, you don't have to write that down technically, but I'm showing you that's why I'm putting over here 2x cubed plus 6x squared. All right? And then you subtract those. All right? And what you get is you get, well, of course, the 2x cubes cancel, and we get, x squared minus 6, so that's minus 5x squared. Then I bring the other things down, minus 3x plus 36. All right, now the question is, how do I get a 5x squared from this? Well, apparently minus 5x times x plus 3 is the way to go. Okay, so that's minus 5x squared minus 15x. Again, the things I'm writing on the side, I usually think about in my head, but if you need to write those down on paper, then do so. So we get minus 5x squared minus 15x. All right? Now I have to subtract those. All right? So then that gives me, of course, the minus 5x squared cancels, and we're left with minus 3 minus a minus 15, which is 15 minus 3, which is 12x plus 36. All right? Then the question is, how do I get 12x from this? Well, I have to add, oh man, I neglected to do what? My bad. Goodness gracious. This is what happens when I have no students in the room, 5x. So you guys keep me honest. So I had that minus 5x goes there, okay. Now to get to 12x, I need plus 12. All right, so then I have 12x plus 36. The remainder is 0, as it ought to be, all right? And so what all of this shows is that, what do we find from all this? We find that f of x is equal to x plus 3, all right, times 2x squared minus 5x plus 12, all right? Now, I think so that's great, but what can we do with that? I mean, this is a quadratic, right? So the question is, does that factor or not? And, I'm not sure, just looking at it. We can do a quick check to see if it factors or not. Let's just quick check the discriminant, right? So the discriminant here, b squared minus 4ac for this thing, is 25, right? So it's minus, I'll write it out here, minus 5 quantity squared minus 4 times 2 times 12, right? And so that's 25. 25 minus, whoa, that's a big one. What's 8 times 12? 96, right? Okay, so pretty clearly that is less than 0, right? And since that's less than 0, that means that this is prime. Okay, so that says prime. And what that means then is that we're done. See, we've completely factored this. So the instructions here I neglected to write down, but I should. So we're given this polynomial, we have this, and then the instructions are factor f of x completely, okay? So that's what I'm after in each example today, is to factor f of x completely over the reals, all right? And so now we've done it because we've shown that that can't be broken down further, right? So there you go, answer right there. So that's example 1. All right, example 2. Let's see here. Suppose we have, excuse me. So example 2 is going to be a little bit different, actually. So what I'm going to do in example 2 is, and I'll do it over here, just so we can have them side by side. Example 2, I'm just going to do a long division, just plain old do it. All right, so I'm going to look at f of x equal to 3x cubed plus 2x squared plus x plus 3. All right, and what is it, Benjamin? Nothing. All right. Check to make sure my mic is working. I accidentally gave a lecture the other day with the mic turned off, which is always a bad feeling. So I'm going to take this polynomial and I'm going to divide x minus 1 into it and see what happens. Yeah? You need to throw away your gum? Well, there's a trash can back there in the, see it? Okay, so to get this 3x cubed, I need a 3x squared. See, then 3x squared times x minus 1 is 3x cubed minus 3x squared. So I put that here. X squared, all right? Yes, Benjamin? I take the difference. Well, you're going to have to wait, you know. Wait till I'm done making this video, then we'll get you his drink, okay? With the water with the cap, maybe, yeah, we'll see. So we take this minus that, and that gets us 0. This minus a minus 3 gives me 5x squared. All right, how do I get 5x squared from x minus 1? Well, I need to multiply by 5x, right? So that gives me 5x squared minus 5x. So I get 5x squared minus 5x. I take the difference here. I almost forgot. I got to write the plus 5x up here, right? So we do that. Okay, great. And then, okay, so I take my difference, and that gives me 6x plus 3, right? 6x plus 3. All right, so then how do I get a 6x from this? Well, I need 6, right? 6 times x minus 1, 6x minus 6. So we get 6x minus 6, we take the difference, right? What happens? Well, what happens is we get 9, right? And once you get something here which has smaller degree than what you're dividing by, you're done. All right, so this is the remainder. The remainder is 9 in this case. That's the remainder. And what this means, right, is that if we take, let me write out what this calculation means. This calculation means that if you take 3x cubed plus 2x squared plus x plus 3, right, and you divide it by x minus 1, what you get, all right, what you get is this. You get 3x squared plus 5x, all right, 3x squared plus 5x, and then plus that remainder term. So plus 9 over x minus 1. All right. So, you know, in this case, you can see that it didn't quite factor, right? If you want to, you can multiply through this. If you multiply this equation by x minus 1, you see what you have is that 3x cubed plus 2x squared plus x plus 3 is actually equal to 3x squared plus 5x times x minus 1, all right, plus 9. So the fact that you have to write a 9 over there basically means that you can't factor, we could not factor x minus 1 out of this polynomial. So this shows, it indicates that x minus 1 is not a factor of f of x. But then we can ask a question, what is the significance? What is the significance of the remainder here? Does it have some significance? And the answer is yes, it does. How does it relate to 1? Well, check this out. If you calculate f of 1, right? F of 1, what is it equal to? F of 1 is equal to 3 plus 2 plus 1 plus 3. Hey, that's 9. All right, that's not an accident. There's something called the remainder theorem, and the remainder theorem is this. So we talked about the factor theorem last class. The remainder theorem says this. The remainder of f of x divided by x minus c is precisely f of c. All right, so that's the remainder theorem. It says if you divide by x minus c, whatever you get as the remainder, that's f of c. All right, and that's what happened here, right? We divided by x minus 1, remainder was 9. Okay, f of 1 is equal to 9. And this remainder theorem, right, it basically reduces to the factor theorem, if you want to think about it that way. What happens if we have f of c equals to 0, the remainder is 0, all right? So like the remainder being 0 means f of c is equal to 0. And actually it goes both ways. So anyway, that's the remainder theorem. So, and also this calculation we did over here, where we're taking, you know, a polynomial dividing by another one, and we get a polynomial piece plus this other piece over here. That's something we need to do more of later. So I'll try to do another example like that here shortly. Let me actually get another one here. Example, but I think I'm going to focus on the factoring for the time being. All right, so example 3. Example 3. Here we have f of x equal to x to the power 5 plus 7x to the 4th minus x cubed minus 43x squared plus 36. All right, and I tell you, you're given that f of 1 equals to 0, f of minus 1 is equal to 0, and f of 2 is equal to 0. Wow, that's a lot of information, isn't it? So what does that mean? And then the question is to completely factor f of x. So all right, so let's see, how do we do that? Well, we can use the factor theorem to get us started, right? So we have, let me erase this other stuff out of the way here. So we have an x, we have what? An x minus 1 factor, we have an x plus 1 factor, and we have a what? We have a x minus 2 factor, right? From the factor theorem, each one of these by the factor theorem gives me a factor. So we've got x minus 1, x plus 1, x minus 2. This is a factor of f of x, right? And you can multiply those out, right? Let's do that. So this is x squared minus 1, the first two. And then we got times x minus 2. And then multiply that out. You get yourself a, let's see here, x squared times x is x cubed, then minus 2x squared minus x plus 2. So the product of these three factors is that cubic, and that cubic, this must be a factor of f of x. Okay, so that's great. How exactly do you factor this out of the given f of x though, right? So we can use long division to do that. And I'll do it over here. So I've got myself x to the 5th plus 7x to the 4th minus x cubed minus 43x squared plus 36. It's important to copy these numbers down right, otherwise everything goes haywire. And then we've got x cubed minus 2x squared minus x plus 2. All right, that's my factor. I'm going to divide that in there. Okay, so typical color coding. I think about, what do I need to multiply this by to get x to the 5th? Well, I need x squared up here. X squared times this gives me x to the 5th minus 2x to the 4th. X squared times that gives me minus x cubed, and then plus 2x squared. All right, so I have to subtract those guys from the one we're dividing into. What do we get? We get, these cancel. This gives me a 9x to the 4th. All right, the x cubes cancel, that's cool. And I get minus 45. I mean, some people insist on writing it down here. It doesn't matter to me so much, but 45x squared plus 36, all right. And I'm sorry, we don't need the line yet, do we? Okay, so great. Now, up next, to get this 9x to the 4th, I need plus 9x. So that gives me 9x to the 4th. Well, let me stick with my color coding here. Well, fine, I guess it's forgotten my color coding already. All right, 9x to the 4th. And then this times that, it gives me minus 18x cubed. There's so much noise in the hall right now. Minus 9x squared. And then plus 18x. All right, so I have to subtract all that. And what happens? So we got the 9x to the 4th cancel. And looks like we've got 18x cubed. All right, let me change colors here. We've got, so I've got 18x cubed. The x squareds give me, let's see here, that's plus 9, right? So minus 36x squared. 36 minus 18 is 8. Oh, I can't subtract these, right? Duh. So then I have minus 18x. Got to be careful, right? 36. All right, so how do I get an 18x cubed from that? Well, obviously, I have to add 18. So plus 18. And so that gives me 18x cubed minus 36x squared minus 18x. I'm multiplying this times that plus 36. Well, that's good. So you subtract these and you get remainder 0. Good. If we didn't get a 0 there, we'd be in trouble. So put it all together, what have we learned? We've learned that we have f of x, I'll write it over here. We have f of x is equal to, these guys, right? I'll write it the ugly way. X squared minus 2x squared. Yes, Benjamin? Look at your drawing. Bring it up here so I can see it. You can bring it up here. Let me see it. What we got? We got What am I looking at here? What's this?
This is a robot.
That's a robot?
And that's a ghost.
A ghost. A ghost and a robot. Very nice. Sorry we don't have any brown markers. We'll get those when we go back. But so we divided this into f of x. That's a factor. And what did it peel off? It peeled off an x squared plus 9x plus 18. Right? And so I can, of course, I can undo this, right? I can let's put that back where it came from, right? Because we're trying to factor f of x, so we know that this was exactly, and of course, if you wanted to save writing, you could have just written this down to start with if you understand what you're doing. I'm just trying to make what I'm doing so you can follow it. So that is exactly that. This over here, it's a quadratic, right? So can we factor that? Goodness gracious. Quiet, quiet. Somebody left me a voicemail. Exciting. All right, so if we complete the square on this, we've got x plus 9/2 squared, right? Minus 81 over 4, because 9 over 2 squared is 81 over 4, plus 18. And I think, oh man, my son stole my calculator today. But I think that 81, oh man, I don't know. What's 18 times 4? 72, right? So, that actually can factor. So 81 minus 81 plus 72 is actually, so like, 72 minus 81 is minus 9, yeah? And so this is actually minus 9/4, and I think I'm going to feel very silly because I think you can, I'm a dummy. What am I doing? So, okay, I have mixed feelings about this. So we can continue down this path of silliness. Some of you if you're following along and trying to do it for yourself, at this point you realize you could have not worked so hard at this, right? Because this guy just factors. But anyway, here's how it does. So that's minus 9/4, which 9/4 is 3/2 squared, right? So that is x minus 1 times x plus 1 times x minus 2 times x plus 9/2 plus 3/2 times x plus 9/2 minus 3/2, right? At which point, if you add those, what do you got? Yes, Benjamin? What about the markers?
I'm done with it.
Are you done with it? Well, just sit there. We're almost done here. We'll be done in just a minute, buddy. So 9 plus 3 is 12. 12 over 2 is 6, all right? So x plus 6, and over here, 9 minus 3 is 6. 6 over 2 is, 3. So we've got x plus 3. Of course, in retrospect, duh, right? Of course, I should have seen that, right? If there were students here, somebody would have helped me. This, right? Did I need to complete the square on all this? Did I need to complete the square here? I don't think so, right? If you could see to factor that to this, then great. This is exactly equal to that. Completely factored, you're done, right? So there's that. So that's example 3. All right, so we've completely factored. Let's do another one. I'm going to jump straight to the long division this time, all right? I'm going to forego the setup, because I'm a little bit short on time here. Example 4. So here I want to divide 2x cubed minus 5x squared minus 6x plus 9. I'm going to divide x squared minus 4x plus 3 into that thing, all right? Okay, so how's that go? So to get this 2x cubed, I need a 2x. All right, so then I'll write it up here. What's 2x times x squared minus 4x plus 3? Well, it's 2x cubed minus 8x squared plus 6x. So I'll put that here, 2x cubed minus 8x squared plus 6x. All right, so we have to subtract these guys, right? And so like when you look at the typed notes that I'm going to give you guys, this minus is already distributed through those in what I'm going to hand out. Anyway, the 2x cubes cancel, and we've got minus 5 plus, well, minus and minus is plus, right? So that gives me 3x squared, and this gives me minus 12x, and I bring down the 9. So I bring down the 9 here. All right. Okay. So how do I get a 3x squared from that? Well, I just do plus 3, right? So this gives me 3x squared minus 12x. 3 times 3 is 9. All right. I subtract. I get remainder 0. Hooray! What does this give us? This gives us that we can factor 2x cubed minus 5x squared minus 6x plus 9. Benjamin, what you doing, buddy? Don't go out there. Okay? Is equal to x squared minus 4x plus 3. We'll be done in just a minute, buddy. Times 2x plus 3. And the question is, all right, so now let me fess up. This is f of x for this problem, all right? And I'm trying to completely factor this thing. I gave information in example 4 that f of 1 was 0 and f of 3 was 0. So like this was coming from I was given that f of 1 was 0 and f of 3 was 0, which gave me that x minus 1 and x minus 3 were factors, which of course is x squared minus 4x plus 3. So that's why we were dividing this into that, okay? That's the backstory for this example. All right, so of course this factors to x minus 1 times x minus 3, and then you got your 2x plus 3, and that can't be further factored, so there you go, completely factored again. So I hope this is helpful. I'll probably add more to this video here with post-editing. Anyway, maybe next time I'll just do, I'm going to use a different format next time anyway. I think that's a good place to stop for here. So I hope this was helpful. Thanks, guys.